Standard electrode potential data are useful for understanding the suitability of an oxidant in a redox titration. Some half cell reactions and their standard reduction potentials are given below. Identify the only incorrect statement regarding the quantitative estimation of aqueous FeNO3 twice. In FeNO3 twice, Fe oxidation state is +2. Option A is MnO4 minus can be used in aqueous HCl. Whether this statement is right or wrong, we can identify by calculating E0 cell value. So first of all, MnO4 minus will oxidize Cl minus ion or not. In MnO4 minus, Mn oxidation state is +7. It is changing into +2. +7 to +2 means reduction. So it is cathode and its E0 reduction potential value is 1.51 volts. Whether it will oxidize Cl minus ion or not. First of all, here given reaction is Cl2 plus 2 electron gives rise to 2Cl minus. It is reduction potential value is given. E0 reduction potential value is given 1.40 volts. I am changing that into oxidation potential. 2Cl minus aqueous gives rise to Cl2 plus 2 electron. Oxidation potential value is minus 1.40 volts. Now E0 cell is equal to E0 cathode plus E0 anode. Here E0 cathode is 1.51 plus E0 anode oxidation potential minus 1.40. So E0 cell value will get 0.11 volt. The E0 cell value is positive. If the E0 cell value is positive, the reaction is spontaneous. Spontaneous in the sense MnO4 minus can oxidize Cl minus. Next, we'll see whether it can oxidize Fe plus 2 or not. So as usual, same like in previous case, actually here it is given as Fe plus 3 plus 1 electron gives rise to Fe plus 2. Reduction potential value is 0.77 volts. I am taking oxidation potential. So Fe plus 2 aqueous gives rise to Fe plus 3 aqueous plus 1 electron. Its oxidation potential is minus 0.77 volts. If we calculate E0 cell value, here we are getting plus 0.74 volts. So here also E0 cell value is positive. So E0 cell value is positive means the reaction is spontaneous. That means MnO4 minus can oxidize Fe plus 2 also. So MnO4 minus is oxidizing Cl minus and also Fe plus 2. That means MnO4 minus is not suitable oxidizing agent, because suitable oxidizing agent means it can oxidize only one, but it is oxidizing both Cl minus and also Fe plus 2. So in the given question, the wrong statement is option A only, because MnO4 minus is oxidizing both Cl minus and also Fe plus 2. That's why MnO4 minus cannot be used in aqueous HCl. Now we'll check why option B is correct. Same by calculating E0 cell values. Cr2O7 minus 2 can be used in aqueous HCl. Its reduction potential value, actually here it is Cr2O7 minus 2. Reduction potential value is 1.38. So first reduction potential value Cr2O7 minus 2, each chromium plus 6, 2 chromium atoms plus 12, and here each chromium plus 3, 2 chromium atoms plus 6 plus 12 to plus 6, it is reduction. So it can act as cathode. So E cathode value is 1.38 volts and it is undergoing the reduction. And then Cl minus 2Cl minus aqueous gives rise to Cl2 aqueous plus 2 electron, means I am taking oxidation potential, same like in previous case. Oxidation potential is E0 anode is equal to minus 1.40. When cathode reduction potential value, anode oxidation potential value is given, then the formula to calculate E0 cell value is E0 cathode plus E0 anode. If you substitute, you will get the value minus 0.02 volts. So the reaction is E0 cell value is negative, so the reaction is non-spontaneous. Means Cr2O7 minus 2 cannot oxidize Cl minus. Okay, but whether it will oxidize Fe plus 2 or not, we'll check it once. So Fe plus 2 aqueous gives rise to Fe plus 3 plus 1 electron. Here also I am taking oxidation potential. Oxidation potential is E0 anode is equal to minus 0.77 volts. Same if we calculate E0 cell value, here we are getting plus 0.61 volts. E0 cell value is positive, means this reaction is spontaneous. So Cr2O7 minus 2 will oxidize Fe plus 2. It won't oxidize Cl minus. So we can consider that Cr2O7 minus 2 is a suitable oxidizing agent because it is oxidizing only Fe plus 2 based on the E0 cell values. So B is correct option.